Okay, so this is going to be our attempt at learning calculus online. Hopefully it'll go okay. I can't write on this computer as well as I can the one at school. I'm working from home, so my writing might be a little hard to see, but I'm also working from home, so if you hear children screaming in the background, that is why. So today we're going to look at 7.3, 7.4. These are slope fields. And slope fields are a device that we can use that gives us a picture of what the possible solutions to differential equations look like. Now, we have not solved differential equations yet, except for solving really, really simple differential equations. So you have had problems like this right here that said solve the differential equation. And to solve this differential equation, what you would do is you would multiply both sides by dx to get that dx out of the bottom here. That would leave you with dy equals 8x plus 4 times dx, and then you could integrate both sides of that equation. And so when you do that, when you integrate dy, you just get y, and over here you're just going to integrate 8x plus 4, and that's going to give you 4x squared plus 4x plus c. So when you solve a differential equation, you really get an infinite amount of answers, because right here this plus c tells us that we could add any number to the end. So if we go to Desmos real quick and just look at this, if we had, let's see, okay, there we go. This is not as easy to use. 4x surely is not as easy to use on here. Let's do this one. Well, I don't know how to do X once here. Right. Okay, so if we go to Desmos real quick and look at this graph that you're seeing right here is just 4x squared plus 4x. But if we added in, we could have that plus c could be a plus 1 or a plus 2 or a plus, so that's another plus 2 again, a minus 1, a minus 2 right here. And so we've got all of these graphs, and that c could be anything. So we could have an infinite number of graphs for this particular problem. So whenever we get a solution for a differential equation, we actually have infinite solutions. So what a slope field does is it looks at the shape of those infinite solutions. So let's go over to the next example, and we're going to actually create a slope field. So this slope field that we have here is for the derivative dy over dx equals 2x plus 1. And so we're supposed to draw a slope field for this. So what we want to do is we just want to look at what the slope of the graph would look like at every single point. So as you do more of these, you'll probably get a little bit better, and you might not need to make a chart. But I'm going to make myself a chart here, x, y, and then dy over dx. Okay, so I'm just going to take all the points on this slope field, and I could make it bigger, but then it's really going to take a long time to make. So I'm going to take all the points on this slope field. So for example, I'm going to start in the upper left-hand corner, and the coordinates of that point are -2, 2. And I'm going to take that x and that y, and I'm going to plug it into dy over dx equals 2x plus 1. And so in this case, the x is the only number you're actually plugging in. So you'd have 2 times negative 2 plus 1, and that is going to give you negative 3. So what you'll do when you get that is you're going to go to the graph over here, and when you go to the graph, you are going to look at this point, and you're going to think about graphing a little tiny piece of a line that has a slope of negative 3. So if you think down 1, 2, 3, and over 1, it would be a slope that would go through those lines, those points there. So I'm going to draw in this little slope right here. Now, it doesn't have to be perfect, just close. And then I'll go to the next point. Well, if I go down to negative 2, 1, well, I'm going to get the same answer. I'm going to get a negative 3 here because the x-coordinate is still the same. So I'm going to have a slope of negative 3 here. And then all of these points in this row where x equals negative 2, they're going to have a slope of negative 3. So all of them have that same slope there. Then I can move over to the next point that I've got, negative 1, 2. And at negative 1, 2, I would take 2 times negative 1 plus 1, and that's going to give me negative 1. So I would have a slope of negative 1 at this point right here. And then I would just draw in all these other little slopes because the x-coordinate's the same at all these. Now, there's not a great deal of difference between negative 1 and negative 3, but these here should look a little bit less steep than the ones at negative 3. My next point that I'm going to test is 0, 2, and here I would do 2 times 0 plus 1, and that's going to give me 1. So I would have a slope of positive 1 here. So I would draw in all of these little slopes here that have a slope of positive 1. Next, I would have 1, 2, and let's see, that was a positive 1 there. And so I would do 2 times 1 plus 1, which is going to give me 3. Mom! So right here we can put in a slope of 3. For all of these, they need to look a little steeper than that slope of 1. And then this last point over here, we would have 2, 2, and if we plug in 2, 2 times 2 plus 1, it's going to give us 5. So these right here would look even steeper than the 3s. So we can sort of get a look at the shape here. This particular problem is also a really simple differential equation. There's going to be several differential equations we'll see we don't know how to solve yet, but dy over dx equals 2x plus 1. We know how to solve that. We could multiply both sides by dx and then integrate both sides. And so that would give us y equals x squared plus x plus c. So you can see here this is a quadratic. If you look at the graph here, you can sort of see that shape of a quadratic here. It might be something like this, but it gives you that shape of the graph for the answer to the differential equation. Let's do another one now. This next one is a little bit more difficult. It is not one that we could just solve because it has an x and a y. In fact, we're not even going to learn how to solve this one because this one is not separable. But we can still look at the slope field for it. So let's make ourselves a table again, like we did on the last one. So we've got x, y, and then our dy over dx. And so I'm going to start again at negative 2, 2. And if I'm doing negative 2, 2, that means that I'm going to be doing negative 2 minus 2. And so negative 2 minus 2 is going to give me negative 4. Okay, so we have a slope right here at this point of negative 4. If we try the next point, negative 2, 1, then I've got negative 2 minus 1. That's going to give me negative 3. And so I'll have a slope just a little less steep right here. At negative 2, 0, I'm going to have negative 2 minus 0. I get negative 2. So I'm going to have a slope of negative 2 here, just a little less steep than the one before. At negative 2, negative 1, this time I've got negative 2 minus negative 1, which is actually like negative 2 plus 1. So that is going to give me a negative 1. It's a slope of negative 1 here. And then negative 2, negative 2. That's going to be negative 2 minus negative 2, which actually becomes a plus there. So I get 0 for this one. And a slope of 0 is just a horizontal line. So you can kind of see that pattern there as well. Negative 4, negative 3, negative 2, negative 1, 0. So as you do this, if you see that pattern, then you might not have to calculate every single one of these. Our next point that we would look at would be negative 1, 2. And you don't necessarily have to start in that top corner. I just kind of like to. And so if I'm doing negative 1 minus 2, I'll get negative 3. So I'll have a slope of negative 3 here. And then negative 1, 1 is going to be negative 2. And you're going to see that same pattern where we're just decreasing by 1 each time. So at negative 1, 0, I would have a slope of negative 1. I would have a slope of 0 here, and then a slope of positive 1 here. Let me erase this so I can continue my chart. So x, y, and dy over dx. Sorry about that writing there. So our next point is at 0, 2. And if I do 0 minus 2, I'll get negative 2. And so I'll have a slope of negative 2 here. At 0, 1, I'm going to get negative 1. So I have a slope of negative 1 here. I'm going to have a slope of 0 next, then positive 1, and then positive 2. Okay. Then I would have the point 1, 2. 1 minus 2 is going to give me a slope of negative 1. Then 1, 1 would give me a slope of 0. And then I'm going to end up with a positive 1, a positive 2, and a positive 3. And then for the last column there, I would have the point 2, 2. So 2 minus 2 would give me 0. And then 2, 1, 2 minus 1 would give me 1. So I'd have a slope of 1. And then I'd have a slope of 2, 3, and 4. Now you'll notice some of my lines maybe aren't perfect, like these, the 2 in the left corner there look kind of the same. But you really just need these to look relative to the other. So your 1 needs to look a little less steep than your 2, and so on. They don't have to be perfect. But this does give you a picture of what the graph might look like. If you had let's say if we had a graph that went through this point right here, well, it would probably follow along these lines, maybe a minimum here and a slant asymptote here. Or you might have a solution that went through a point down here, and if it went through a point down here, it would follow more this curve like this. So depending on what point your solution goes through, it may look different for these graphs, but it gives you a general look at what the solution would look like. Okay, so some of these problems you will have to create a slope field. There will be others that will be multiple choice where you have to examine a slope field and talk about the answer. So let's look at a couple of those. Here, for example 3, they give us a slope field, and this slope field is much more detailed than the ones we just made. It has a lot more points than we had, and it tells us the slope field for a certain differential equation is shown above. Which of the following statements about the solution y equals f of x to the differential equation must be false? And then it gives us several things. It says here for A, it says the graph of the particular solution that satisfies f of -3 equals 2 is concave up on the interval -3 less than x less than 3. So that particular solution, as I said, there are infinite solutions to differential equations because of that plus c. A particular solution is one of those, so it's one certain value for that c. And this particular solution satisfies f of -3 equals 2, and so that tells us that this solution goes through the point -3, 2. So if we go to our graph, -3, 2 is right here on the graph, and if we think about what a solution through that point would look like, it's got to follow the lines of the graph. It might not exactly look like this, but it's probably going to follow something like you see here. And if we look at that, it is concave up everywhere, which is true. This was looking for false, so this one is out. Okay, the next one says that we have a particular solution where f of -2 equals -2. So -2, -2 is about right here on the graph, and it has a relative minimum at x equals -2. Well, if you look right there at that point, if we can get that sort of go away, you have a zero slope right there at -2, -2, which tells us that we do probably have a minimum value right there. So that appears to be true. We're going to exclude that answer. For C, it says the graph of the particular solution that satisfies f of 0 equals -2 is concave up on the interval -1 from -1 to 3. So we're looking at 0, -2. So 0, -2 falls right here on the graph. And right here, if we follow the lines of the graph, we're going to get a graph that maybe looks something like this. Sorry for the bad writing. This is hard to write on. And this is concave down. So this appears to be false. So we're going to choose C. And then D, the graph of the particular solution that satisfies f of 1 equals 0 is linear. And so if we look at that one, f of 1 equals 0, so 1, 0 is right here on the graph. And you can see right there we have all those tangent lines that are the same right there in a row. So that does appear to be linear. This D appears to be true. So C would be the correct answer for this problem. Okay. Next, we're going to look at example 4. And example 4 says the slope field for a certain differential equation is shown above. Which of the following could be the particular solution to the differential equation satisfying y of 0 equals 0? So we're looking at the particular solution that goes through 0, 0. So right here on the graph, we're looking at the solution that passes through the origin right here. And so if we think about what this is going to look like, just sort of following the curves of the graph, we are going to have something that looks like this. It appears that there is a horizontal asymptote right here at -1. So this is sort of the shape of the graph that we're going to have. There's a couple of these that we can eliminate really easily because we just know what the shape of the graph looks like. So for example, A is a quadratic. A quadratic is not going to have a horizontal asymptote. The quadratic would go back up at some point, so A would be out. B is a sine graph, and a sine graph is going to be repetitive like this. We don't see any indication here on the slope field that that's the case, so we would throw that one out as well. C and D are a lot more difficult to do. It might be helpful here to think of this instead of e to the negative x minus 1. You could think of it as 1 over e to the x minus 1. And if you think about doing the limit as x approaches infinity here, as x gets bigger and bigger and bigger, this part would become 0. And so you would have a horizontal asymptote at -1. So that is a possibility. But for D, we also have the same thing. We've got e to the x squared minus 1. Mommy. Okay, so here we would also have this as x approaches infinity, this would go to 0. So we'd also have a horizontal asymptote at -1. So that doesn't really help us a lot for this particular problem. So what we could think about is we could think about taking the derivative of this. If we take the derivative, so if we take the derivative here, oh no, bud, go get him. Don't really go outside. All right, so if we take the derivative here, the derivative of e to the x is e to the x, but this one's going to require just a slight chain rule. So we're going to have e to the negative x, but then we must multiply that by the derivative of negative x, which is just -1. So our derivative here is negative e to the negative x, which is the same as having -1 over e to the x if we move that negative exponent back down to the bottom. So if we just think of a point, for example, if we think of the point where x is 0, then if we plugged in 0 right here, we would have -1 over e to the 0, which is -1 over 1, which is -1. And if we look here, that's possibly, right there at that point, that's possibly a slope of -1. So that is a possibility. Let's try that same thing for D. So if we take the derivative for D here, y prime would be e to the negative x squared, but then we would have to multiply this by the derivative of negative x squared, which would be -2x. And so if we rewrite this, that would be -2x over e to the x squared. And so if we plug in 0 to this, we would get 0 over e to the 0, which would be 0 over 1, so we'd have a slope of 0 right here. And if we look at our slope field right here, we do not have a slope of 0 right there at that point. So that would tell us that C would be our best answer. One thing that you can do here to help you, now these are technically calculator inactive, but something that you can do to help you a little bit if you're getting stuck, if you go to Desmos, and let's clear these out, and if you graph your answers, y equals e to the negative x minus 1, you see that graph fits really nicely with what you see on the picture of the slope field. But if you do e to the negative x squared minus 1, you see we get this graph right here. And this graph does not match what you see on that slope field. So C is your best answer for this one. The last problem that we're going to look at is going to be a part of a free response question. And we're going to do part of this. It normally would have a part C, but we're not going to do that part. So this may show up on the actual AP exam, assuming we get to that. And so we've got a differential equation, dy over dx equals 2 minus y over x, and we need to sketch the slope field. So I'm just going to make myself a chart here for this. And for this chart, we've got x, y, and dy over dx. And so we would have, if I start right here, we'd have the point 1, 1, 1, 2, 1, 3. Then we'd have 2, 1, 2, 2, and 2, 3. And then we would have 3, 1, 3, 2, and 3, 3. Now, if we look at what we've got here, we're doing 2 minus y over x. So for this one, we'd be doing 2 minus 1 over 1, and that would just give us 1 here. So we'd have a slope of 1 for that first point. And then 1, 2, we'd have 2 minus 2 over 1. That would give us a 0. So we have a slope of 0 right here. And then we'd have 1, 3, so we'd have 2 minus 3 over 1, and that would give us negative 1. So we'd have a slope of negative 1 right here. Going down for 2, 1, we'd have 2 minus 1 over 2. That's going to give us a slope of 1/2. And so we have a slope of 1/2. It'd be a little less steep than that slope of 1. For 2, 2, we'd have 2 minus 2 over 2. We're going to get 0 right here. And then for 2, 3, we'd have 2 minus 3 over 2, which would give us negative 1/2. So we'd have a slope right here of negative 1/2. For 3, 1, we'd have 2 minus 1 over 3, which would give us a slope of 1/3. So we'd have a slope of 1/3. It's going to be a little less steep than that 1/2. At 3, 2, we'd have 2 minus 2 over 3, which would be 0. Again, you're seeing right there, everywhere where that y coordinate is 2, we're getting 0 for our slope. And then at 3, 3, we'd have 3 minus 2 over 3, which would give us a negative 1/3. So we'd have a slope of negative 1/3 here, and that would be our slope field that we'd be asked for. You can't see the graph all that well. You can see there's probably a horizontal asymptote too. And as we go a little further, we'll learn how to solve those, but we're not going to do those right now. Now, the second part of this graph, or this question, is going to ask you for a tangent line. It says, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 3 equals 1. Write an equation for the tangent line to the graph of y equals f of x at x equals 3. Use the equation to approximate the value of 3.5. So for a tangent line, we need a point on the graph and the slope of the graph. So the point on the graph is given to us right here, that f of 3 equals 1. So we know the graph passes through the point 3, 1. The slope is going to be the derivative. Now, since we've already done the slope field, we could just look up here at the point 3, 1 right here. At the point 3, 1, we had a slope of 1/3. So 3, 1, that's this point right here. And so we have a slope of 1/3. Or we could just plug 3, 1 into our derivative and we'll get 1/3 as well. So our slope, which is the derivative at x, y equals 3, 1, that is going to be 1/3, right? And so to write this tangent line, we're just going to use that point slope form. Y minus 1 equals 1/3 times x minus 3. Okay, so this would be our tangent line. And then if we want to use that tangent line to approximate f of 3.5, we're just going to plug 3.5 into this tangent line for our x. So we would have y minus 1 would equal 1/3 times 3.5 minus 3. And that is going to be y minus 1 equals 1/3. 3.5 minus 3 is 0.5, which is also 1/2. I'm going to switch to fractions here just because I think it'll be a little bit easier. And this would not be calculator active. And so we end up with y minus 1 is 1/6. We're going to add the 1 to the other side. So y is going to equal 7/6. So we would say that f of 3.5 is approximately 7/6. over 6, and that would be our approximation here. So that sort of covers what you're going to need to know about slope fields. And you're going to have an assignment that goes with this. The assignment, so I thought I had it on here, but I don't. The assignment has 3 parts that you're going to do. And I'm actually going to pause this so I can go over and show you what that looks like. Okay, if you will go to Canvas, and you should have found this video under modules, and the video was right here, but I'm making the video now, so it's not there yet. There are 3 assignments that I want you guys to do. 2 of them are going to be for a grade. 1 of them is just sort of on your honor. It will help you for the others. The first one is this worksheet, and on this worksheet, just do 1 through 16. You do not have to do 17 and 18. This is the one that does not count as a grade, but I'll click here to show you what it looks like. Actually, it gives you a preview there. So it's got several slope fields, some multiple choice questions. You'll answer those. And if you'll look below here, there's the key so you can check your work. The next 2 parts of the assignment are going to be required, and they are going to be due on Wednesday by midnight on Wednesday. And the next is a slope fields matching activity. And if you'll click here, there is a chart here for you to put your answers on, and it's basically some cards. You've got 10 different differential equations. Then you've got 10 different slope fields that you have, and then you've got 10 different conclusions that are made. So you have to match each slope field to a differential equation and a conclusion. And you can record your answers here on this table. And the way you're going to submit this assignment is you are going to go over here to the quiz here, the Canvas quiz that you'll see right here where it says slope field matching, and you will take the quiz, and you will just select, like, if slope field 1 goes with DE5, your differential equation 5, and your 8th conclusion, then you'll pick those here. Now, those probably aren't the right answer, so don't pick those. And then you'll submit that, and you get 5 submissions on that quiz. You have to make at least an 85 on that to get credit for it. So whenever you submit, it should tell you which ones you got right and which ones you missed. And then you can try again after that. If you have questions, you get stuck, you're about to run out of submissions, you are welcome to email me or call me and let me know what questions you have. And then the last thing that you're going to do is you're going to do an assignment on AP Classroom. This one only has 5 questions. It will be for a homework grade. Since there are only 5 questions, I'm not going to put a minimum correct score, but I would like for you to take that seriously. Number 5 is a free response question. Please upload your solutions for that. If you can take a picture of whatever you've done and upload it there. Normally I just have you guys do those on paper, but I can't do that since we can't actually turn anything in. So please upload those. You do not have to do 5C because it is not something we know how to do yet, but I couldn't get rid of that part of the problem, so just leave that part blank for me. So those are your assignments. I need to add right here. All of this is going to be due by midnight on Wednesday. So please have that done by then. These will be for homework grades, and if you have any questions, just let me know.